lost the signal, but I found the way. No phone, alone on the highway. Lost the signal, but I found the way. Call me alive, alive today. Hot sun, top down in the fast lane, 1009. More miles to go, but I make it good time. I learn each turn, I'm just guessing, but I feel total control. Now my hands on the wheel. Lost the signal, but I found the way. No phone, alone on the highway. Lost the signal, but I found the way. Call me alive, alive today. The signal found my way. Lost the signal. Lost the signal.
Hey guys! I'm still hurrying over here trying to get all the things prepared. But, well, let's just start the stream. Hey! How's everyone doing? Let's turn the music down a little bit. There we go. And let's share this on the YouTubes. Or, well, it's already shared on YouTube. Let's share this on the Discord. Let me get a link. And there we go. Right. So who's all here? We have 90 people already. Nice. Let's see here. Philip's here and ECZ G-Man Andy, or Andy I should say for short. Those are the two moderators on the Discord, which I thank a lot. And let's see. Jeff Hammer is here. DJ Quinn. Oh man, was waiting for the drop. Oh yeah. Stefan van Roy just put 300 meters of network cable in my house, so lights with POE are awesome. Well, we're going to see if that's going to work. Air Cookie is here. Hey, for those who do not know, Air Cookie is the main developer behind the WLED software, so that is awesome. Pablo, hey Quinder, looking forward to an interesting stream. Yeah, well, I'll try and make it interesting for sure. Cool. Sounds like an interesting episode. Well, this is live. This is actually going on. Can everybody hear me and see me okay? POE. Oh yeah. I thought, with all those people trying to annoy me with POE and are you going to bring out a POE board? Let's do something with POE. And no, there's not going to be a POE board. But we're going to do POE anyway. Stream is fine. All good. Yeah. Woohoo! Nice. Okay. Well, let's give it 2 minutes for people to arrive and then I'll start to do my stuff. Let's see. Because we're going out in 4K today. Okay. PC seems to be handling it. That's good. Maybe you will show a preview of the new Dig-Quad too. Yes, everything we're going to do today is on the new Dig-Unos and Dig-Quads. Where's the bar? What? Singapore, it's 3:18 a.m. Damn, okay, hello. It's, 9:18 over here. QuinLED ESP32 POE in the description sure makes it sound like it's a proper board. Yeah, well that's kind of the running gag. There isn't going to be a dedicated POE board, but guess what? You can run POE with all my boards. Hey? Yes, I need a drink. Where's the bar in this chat? I don't know, man. Right, kick it off. Let's get going. Let's make some nice digital smoke. Oh yeah. This is where the cool kids come to hang out, for sure. Yeah, although it's getting warmer outside. What's up, Gwinder? Let's blow up some boards. Let's hope the boards don't blow, but who knows? I mean, I literally... Okay, I've tested one single thing, but other than that, I haven't done any testing. Just had a few pint beer garden. Okay, shouldn't be watching or drinking more. Both. Do both. That's all fine. Okay, so... little backstory, I guess. No, don't need the browser right now. There we go. Chat better. If we look at what's becoming the QuinLED-Dig family, we have the new QuinLED. I guess I should zoom this in a little bit more. Hold on. Focus. Yes. We have the new QuinLED ESP32, and we have a normal board variant with a, board antenna like you can see here. And then we have the AE So this is called a QuinLED ESP32AB, and this is called AE, which has, well, an external antenna. And you've probably been seeing more of those because we've been doing some trial testing with those, etc. These two will be mass available, I'm hoping, starting next week. Fingers crossed. How do I cross my fingers? I don't know, but hey, we're really working hard at it behind the scenes. These should be available shortly, and will also be the basis or put on all the QuinLED pre-assembled boards going forward. So, okay. Now, there's a third variant of the QuinLED ESP32, and that's basically this ESP32 board, but then with an Ethernet board put on top of it. This was a prototype version. This is the trial production run version. We have 100 made right now. My Discord admins and soon AirCookie, although he didn't know it yet until he joined this stream, will be testing this. And if all that's working well, I'm hoping to put those live next week too, so we can get the trial batch out. And then, it's an ESP32 board with Ethernet. And it'll work on the Dig-Uno and the Dig-Quad. It'll even work on the previous versions of the Dig-Uno and Dig-Quad, although with some limitations. But there's documentation about that on QuinLED.info. So let's move this one away. We're not talking about that. Today we're going to take a look at using Ethernet with WLED and to power a QuinLED board and or to power LEDs. And whenever this running gag came up, it was basically like, if I mentioned there was going to be an Ethernet board, others would say, oh, is that going to be POE? And, well, this board itself will not do POE, because then it would have to be at least twice, maybe 3 times as big, and then you'd only have a few watts of power anyway, so it's not going to do POE. Now, I'm just going to mount this on here. So now we have one of the new QuinLED-Dig-Unos. Let me refocus that real quick. Nope. I guess. So this is one of the newer V3 boards, which will be coming out soon. They're currently in production. And, well, this way you can mount an Ethernet connector on top. And now if you wire it up normally and you plug in an Ethernet cable, it'll basically work. So let's take a look if there's any questions so far. Literally crimping cables and wiring up while you stream. Nice. Ethernet will be great for running lots of LEDs and WLED from stuff like X-Lite. Oh, absolutely. And even without it, the interface is just so much snappier. It's amazing. We still want proper PoE. Well, we'll look at that. We'll look at that. So first, let's take a look at the new dig boards. So we have, I'm running out of screen space. Okay, let's do it like that. There we go. We have the new QuinLED-Dig-Uno V3, and then we have the QuinLED-Dig-Quad V2. And those have some interesting new features. They're more geared towards using an ESP32 only. So we're kind of dropping ESP8266 support. I'm not sure what I'm going to do with the DIY version there, but hey. And then, so pinout has changed a little bit. I have articles about this on the website, and that's all coming up. And so geared towards the ESP32, and then with Ethernet in mind, because Ethernet itself takes up 10 pins of the ESP32. So I had to change some stuff around to make that all work. One of the other things the new pre-assembled V3 and V2 bring with it is you can see that there's lots of SMD chips over here and over here. And that is what I call my new DC to DC circuit. In technical terms, it's a buck boost regulator, but basically what it means for the end user, you guys, is that you can now input 5 volt to 24 volt and the board will always work, and, well, there is no longer a power jumper. anywhere. There are no power jumpers because it's now auto input 5 to 24 volts and auto input switching. So even if you use 5 volt EXT next to your main power inputs, and I even added 5 volt EXT pins over here, it's still auto. So it's auto everything, I guess. One thing though to keep in mind, and I mentioned this in the previous video, input voltage is still going to be output voltage for the LEDs. So don't think you're going to connect 5 volt LEDs and then 12 volt power. You can connect 12 volt to 5 volt EXT, and that's a pre-assembled only feature. 5 volt EXT on the DIY boards will remain 5 volt, so be mindful of that too. But you can connect 12 volt to 5 volt EXT on pre-assembled and then 5 volt for main power. But if you have 5 volt LEDs and you connect 12 volt power, well, the board will be fine, but your LEDs will certainly not like it. So, yeah, be mindful of that. No more jumpers. Nice. Yeah, there is still a jumper on the Dig-Uno for GPIO selection, but that's basically for software compatibility. It's not really needed anymore with an ESP32, but I decided to keep it on there. But yeah, no more power jumpers, but still be mindful while connecting LEDs. I wouldn't be surprised if I blow up some LEDs tonight because I'm connecting the wrong voltage to them. So Air Cookie says, if it's a buck boost, do you know what is technically the lowest input voltage for EXT power? Yeah, that's basically, I've tested the boards from 4.5 volts to 26, I want to say. Yeah. So anywhere between that range will run 5 volt EXT just fine. But I'd keep it at 5, 12, and 24 volts. Yeah, but basically anything should work. And it's also non-dependent on each other. So you could have 24 volt, 5 volt EXT, and then 5 volt LEDs. Or you could have 24 volt LEDs and 5 volt EXT, or any combination you'd like, basically. And I know it's confusing. This connector is still called 5 volt EXT. But as I said, on the DIY version, that will probably actually remain 5 volt. Just on the pre-assembled version, because, well, I'm able to make this kind of circuits. Well, I've been able to add more functionality, basically. So the pre-assembled and the DIY are going to differ a little bit. Let's see. Do you have any questions? Can the Dig-Uno with POE control a relay so as to power on and off the power supply and LEDs for saving power reasons? Yes, and that is actually Zorjan. That is actually the main reason why I've built it. So, or designed it, whatever. 5 volt EXT, and they're over here on the Dig-Uno, is meant to keep the board electronics online while you power off your main power supply, be it with a smart switch or with a relay or manually turning off, whatever. And basically what I see POE as useful for is keeping, again, the board online, so feeding the POE into this 5 volt EXT function, basically. We are going to try running LEDs off of the POE, but that's going to be very limited, and, well, we'll see if that's actually a viable scenario or not. It's kind of iffy. 4.5 volt might just be low enough for it to work on a LiPo for a battery-powered project. Well, okay, so in testing, I know the board boots up with 4.5 volt, and I think it'll stay online up to 4.3 volt, and after that, it drops out. So, yeah, you have boards, so you can test it. Oh, Zorjan, don't post questions twice. I'll try and get to them. Doing SMB, I think you mean SMD by hand, is not fun. Well, these won't be fun, but these are pre-assembled, so I use a lot smaller components than I do on the DIY versions. So, hey. Okay, so let's take a quick look at that 5 volt EXT function, and I need to zoom this out a little bit, because I need to have more in the shot. Oh no, what happened? There we go, that should be sharp. So let's say we have a board like this, and we add a... I don't actually know if there's firmware on this controller. It doesn't matter for the demonstration. We add an ESP32, one of the 3 variants there are. And here you can see 5 volt EXT, and I've wired it up plus and minus, and there's a special relay output here. This is a trial board, so it doesn't have the special Q1R pin. The production versions will have a Q1R here, so you can have a GPIO output, which will actually output 5.1 volt. So it'll be compatible with more relays and stuff like that than the 3.3 volt that's normally on the GPIO pins. Okay, so I connected the little adapter which goes to 2 wires and then has a USB-C plug. So if I now plug in a random USB-C power supply I have over here, the board lights up and the ESP32 lights up, and in theory that boots WLED. But I meant the Dig-Uno controlling the relay and not an external controller. Yeah, if you connect a relay using the GPIO pins to the board, that'll do it all automatically. Yeah, you can use a power bank, that's fine too. Yeah, sure. So, yeah, so this way the board is online, but the LED outputs actually isn't. So let me connect some LEDs. Let me get some 5 volt LEDs. And as I said, I don't actually know if I flashed WLED on this specific controller. Let's see here. So I have a roll of 300 WS2812B Eco, I believe this is. Now let me power the board using USB again. And this is online, but it's not outputting to the LEDs because we're using the 5 volt EXT input. That only keeps the board electronics online, but doesn't activate the outputs so that you don't have too much wasted idle power, because each and every LED here is a separate little tiny controller inside of the LED, and that means even when they're off, they draw power. So that's why I created this special 5 volt EXT output. Now let me connect up a power supply real quick, because then I can show you. This is 5 volt. That's good. That's what we need. And let me use my fancy new screwdriver. This will be in a QuinBox soon. Still learning how this works. Okay. And let me connect this. Okay. Now I have a switch over here which I can turn on and off the power supply. So again, we now have LEDs connected. If I connect USB, the board boots, but nothing else happens. Okay. So now let me turn on the power supply. I think this is all correct, and it's 5 volt. Let's hope WLED is on there. Don't actually know. Okay, we have LEDs lighting up, right? So WLED is actually on there. That's good. And, well, now we have output, but when I turn off the power supply, well, the output goes off. So now let's turn on the power supply. Okay. And let's connect 5 volt EXT. That's fine. Nothing happens. That's built to work that way. And, oh, I guess I'll actually need to connect to these LEDs real quick. Hold on. Let me see if I can find it. It's not showing me an access point right now. Maybe I turned it on and off too much. Come on. Okay, I'm not seeing a WLED access point right now. Why not? Well, we're going to have to reflash this ESP. because I don't know what's on there right now. It's fine. I have a cable prepared for everything. Well, no. Oh, I don't have a cable prepared for everything because my own modules are USB-C, of course. We got this one here. Okay, let me start the flashing tool real quick. This is a Dig-Quad V2. Let's see what the chat is saying. Yes, you can drive a relay, has to have 3.3 volt support, no temperature. Uno has temperature sensor. Yes, actually, the Dig-Uno pre-assembled won't have the temperature sensor included because I had to save some costs because we're now including an ESP32 of the board. But the pads to add it are still there and easy to solder. Oh yeah, Philip was already saying this. Excellent work. Can the LEDs get too warm when rolled up? Yeah, especially if you're not doing a pattern, but like static colors, that's not recommended. But I'm just going to do things low power here, so don't worry about that too much. Okay, that finished flashing. So let me put it on the board and see if I see an access point now. There we go. Okay, we're getting WLED orange again. There we go. Okay. So let's go to the controls and let's move this away so I can actually see what I'm doing. There we go. And let's make this, well, let's first configure it for, oh, it's right. Okay. It's configured for the right amount of LEDs, but let's make this 200. And let's say I have 100 over here. Okay, so now you can see a few of the LEDs, and, well, I actually changed color, because, well, basically what I'm going to do now is I'm going to plug this back into my power supply. There we go. I'm going to connect 5 volt EXT. Is the music too loud, or is it okay? Let me know. I'll turn it out slightly. So this is now displaying purple, whatever. It's not displaying the boot orange, basically. We have 5 volt EXT connected, and we also have main power connected. And in this case, everything is 5 volt. Doesn't really matter too much. So now I turn main power off, but the controller stays online because it's still being fed by the 5 volt over here. And let's turn main power back on again. And it's still the purple instead of that the board rebooted, because then it would be orange again. So let me, I don't know, turn it off again. And let's turn it on again. Right? So, and to prove that the 5 volt EXT is doing this, let me disconnect 5 volt EXT while the board is on. If I turn it off now, well, it goes off. And if I turn it on again, it comes up in orange because now the controller is rebooted. So that's basically what I wanted to show you of the 5 volt EXT function. And that's basically the second power you can add to the board to keep the board online while you turn the main power supply off. Oh, Air Cookie actually likes the music. Even, let's see. Even kijken. I'm regressing to Dutch here, sorry. Maybe show it. Okay, yeah, let's see. So this is a, okay, I'll have to zoom in for that. Nope. So looking at this board, you can see that the pads for the temperature sensor are still there, but it's not included this time. And if you, well, it's hard to see, hold on. Oh, we're not going to need this one anyway. If you look over here, I don't think you can see it. the temperature sensor on a Dig-Quad is still included on the pre-assembled. So if you buy a pre-assembled Dig-Uno, it now comes with an ESP32, but you don't get the temperature sensor. But those are easy to buy, like 50, 60 cents, something like that. And you can solder it on yourself. It's just 3 pins. And the resistor and the capacitor needed for it, those are still on the boards because they're like pennies. So I do still include those. But I had to save costs somewhere, and I thought, would people rather have an ESP8266 with a temperature sensor, or would they rather have an ESP32? And I thought it would be the ESP32, especially with the new multi-pin output and stuff like that. So, yeah. Still think you should market it as a Dig Duo. Well, I'll be calling it a dual. It's actually on the board over here. 2-channel digital LED controller. So I mention it and I list it in the specs, but the device itself is still called a Dig-Uno. Since if you use a clocked LED strip, so then you'll use LED 1 and 2 for a single LED strip, you can still only control one strip. So, yeah. Let's see here. There's a user mode for this, yes, called temperature. Not saving the last status is hardware or software related. Well, you can make a preset of what you want it to boot and then tell it to boot that preset. But WLED by default boots up, well, with its default. But you can change the defaults, basically. If the XT power is connected to the board, will it also be used if the main power is on and if there's a switch? It depends. Basically, it depends on which of your inputs has the highest voltage. If 5V EXT is higher than main voltage, it'll use the 5V EXT. But if main voltage is higher than 5V EXT, it'll draw from main. And if they're exactly the same, it'll kind of load balance it a little bit. Okay, so we had... There's a lot to digest in this stream, so I'm going to ramble through it. So, let me focus that. Okay, we had to go through. Is the desk too dark or is it okay? Let me add a little bit of light. There we go. Ah, 200 people here, nice. So we had to go through this whole story about 5V EXT because that is what I think POE is going to be useful for. Replacing this USB connection for 5V EXT with POE and thus keeping the board online while you switch on and off your main power supply to save power, basically. And well, you can also use the QuinLED ESP32 ABE for other stuff like sensors. There's a complete pinout on the back so you can use it for sensors and all kinds of other stuff. But basically low power things, and LEDs aren't low power things because we generally connect like a 20 amp power supply, and while POE it can't deliver that. So let's do a test. Let's whatever, let's disconnect this stuff. Because as I said, the basic principle of this is to keep the board online while main power is off. Basically, like we just displayed. I'm going to start with the cheapest POE splitter I have here. So basically what we're going to do, instead of having POE on the board, we're going to use an external block. And this one I believe was $4 or $5. I have some links down in the description. And basically what this does, this activates active POE and then takes 44 to 56 volts in and then outputs it as 12 volt 2 amps. And as I said, 5V EXT on the pre-assembled boards can take up to 24 volt. On the DIY boards, it's 5 volt only, but we're going to look at different POE injectors in a minute. Now, as I said, this is the cheapest one I have, so let's see if it works with that. So we're going to plug in this guy. So we have Ethernet on this Dig-Quad. We don't need this one right now. We're keeping 5 volt main input power. We don't need the USB wire also. Okay. And, well, we need to get this into the board. But luckily, these kind of things are cheap nowadays. So we're going to use one of those barrel to 2-wire pin connectors. And then I don't think I have some wires prepared. Oh, we can use this one because I do have wires prepared. Okay. So we're going to take that 12 volt 2 amp and we're going to put that into 5 volt EXT. And then we have Ethernet coming out of the splitter. That is now Ethernet without power on there. And we're going to put that into the Ethernet. So let me wire that up real quick. Come on, there we go. So now POE is only going to serve to keep the board online instead of also powering the LEDs. We'll take a look at that later. Don't worry, don't worry. Let's see what the chat is saying. This looks great. Just think I better start ordering now or I won't get it for Christmas. These are going to sell like hotcakes. Yeah, we're working really hard to get new stock. The goal is still end of April. We might slip past that for like a week or so, but we're really close to getting these new boards out in volume. So that's going to be available soon. Okay, so we have plus and minus connected, and we have Ethernet connected here. And now let's keep main power off and see if the board boots like this. So let's, I don't know, let's plug this in. You can see that the adapter coming online, so it's asking for POE. And there we go. That was easy. The board is online, so the board has power. The ESP has power, and actually you can see the blinking LEDs of the Ethernet socket on the QuinLED-Dig-Quad with the QuinLED ESP32 ABE. There's too many acronyms here. But yeah, well, this is already working. So that was easy. Okay. Yeah, cool. So this is now providing 12 volt for the board, but because this is a pre-assembled, we can input 12 volt into the 5 volt EXT, and that will run the board just fine. It's all internally converted and stuff like that. Okay. But we don't have LEDs on because we're only using 5 volt EXT. Now let me disconnect this real quick. Happy Dutchman. Oh yeah. Hey, as I said, I didn't really do any testing before doing this live stream, so you're here with me, guys. I mean, okay, let me turn on main power. Okay, yeah, this board is configured for, oh wait, we're not gonna get to the Ethernet. Okay, let me get the Ethernet real quick. And let's see which IP it got. 105. I need to configure those LEDs real quick because it was set to APA 102. Oh, okay. Yeah, I had a botched firmware on here. Okay, well, it doesn't matter. I think this will work. Okay, so let's turn on main power, 5 volt. Okay, we get 300 orange LEDs now. I don't have a network connection because Ethernet is disconnected, but let's connect Ethernet and see if it explodes. It shouldn't. Okay, now I have the interface. So I can just, you know, change the colors and stuff like that. Let's put it on a nice effect. Let's do fireworks starburst because it's nice and moving. Okay, so now we have main power on and we have 5 volt EXT, which is actually feeding 12 volts, but okay. Huh? And that's running. So now let's turn main power off. like you could do with a relay connected to a GPIO pin, then that'll work automatically. Okay. Main power is off. The board is still online. Ethernet is blinking away. Okay. Let's turn main power on. And there we go. So before I used a USB connection, because that's basically how I always said you could use 5V EXT. Just connect an old phone charger, at least 1 amp or something like that. And that'll work fine. But now with the pre-assembled version, you can actually input 12V like we're doing here. And, well, if I now turn power off and turn power on again, according to the board and the ESP32 and everything like that, nothing changed. And that's why I'm not making a PoE board. Because this adapter costs like $4 or $5. I don't think I could integrate it into this board without making it twice as big, and then it'd still be more expensive than just adding this. So basically, I've already solved the issue by having 5V EXT, and the new Dig-Uno actually has 5V EXT pins here. They're just DuPont connectors, or pin headers. And, well, that's why I kept saying I'm not going to put PoE on these, because, well, I don't need to. Yes, only V2 and V3 for Dig-Uno. Yes, 5V EXT is basically treat 5V EXT as 5V. But if you have one of the new pre-assembleds coming up, that you can make an exception. I know that's confusing, but that's basically why I'm keeping the port name 5V EXT. So your first thought will be, oh, that needs to be 5V. That is correct if you're doing DIY or have an older board. But as you can see, this is currently doing 12V into 5V EXT for the new pre-assembled. What's the pin? You mean these things? Those are wire ferrules. Philip or Andy can probably paste a link from my equipment guide. Now it's a funny, happy Dutchman. Oh yeah. Okay, so this is also the first test of this cheap adapter. Yeah. If it just works, it works, right? And again, if you want to have a relay on your big power supply, I'm using a button to turn it on and off. You can just take one of these. I have one over here, actually, because I've been testing it. You can take one of these cheap relay boards. They're like $1 or $2. You run some DuPont cables here, and you run the AC wires through here or the DC wires. I recommend the AC wires because then you can carry a lot more current. And you can turn the whole power supply on and off while your board... I'm just going to keep doing it. While your board stays online like nothing ever happened. That's it. Is there a PoE to 5V instead of 12V? Would work for old versions then? Yes. Because, as I said, this is the cheapest one I have. But basically, this is the first thing I wanted to show you. First, I needed to explain that there is now an Ethernet board. Then I needed to explain that the boards have a special second power input terminal to basically keep the board online and regulate where all power goes and what needs what, etc. And now let's talk about these PoE adapters, because one of the things I can now also do. Oh, well, Ethernet will go offline because, well, that's my Ethernet connection. But, yeah. I can also take this in and out. And while main power is connected, they'll run, just keep on running. You know, board will stay online, all fine, that's fine. I mean, I can keep doing this. Let's see, Ethernet's back online. Is it going to be blinking? Oh, this doesn't blink, this blinks. Okay. And now I can turn off main power again. And turn it on again. And there we go. So now you can keep your board online with PoE. Okay, let's turn that off real quick. Then somebody just asked a question, can you also do this with 5V? Yes. So let's first take a look. As I said, I have this 12 volt PoE splitter here, but I have lots of PoE splitters, and most of them are listed in the description. This one is, this one is 5 volt. Probably can't see that. 5 volt, 2.4 amps. Okay. Let's see. I have lots of them here, so let's unpack them. This one is then probably 12 volts. Yeah, this one is 12 volt, 2 amps. Because I said we're going to do testing. Well, then we have to have stuff to test. This is another one. This does 12 volt, 1 to 2 amps. Okay. And then I have these, and these were, well, easily the most expensive. I showed them off in a QuinBox. Because these are really nice, and I have 2 of them. Let me unbox them real quick. Now you need to integrate a relay to remotely disable the power supply. No, I can add a relay to the board, but that would make the board a lot bigger, and not many people would use it, and so it's difficult to integrate features not most people will use. But you could just add a $1 or $2 relay, and then it'll work fine. So these boxes are the more expensive one. I've listed those in the description too. And this one does 5 volt, 4 amps out. So that in theory should allow us to drive a decent amount of LEDs, I hope. And this one allows us to do 12 volt, 2 amps out. Okay. So, and what I like about these, you can have your power input here. But then it just has a normal barrel jack and the Ethernet out without the PoE. And let's take a quick look at the 5 volt one. Yes, that's this one. Let's move this away. We'll be testing that later. Because what this also means is that you can now... Wait, I need a cable and I don't see it anymore. There we go. If we take this one, for instance, if you just want to run some sensors or something else, what you basically do is, okay, this is our Ethernet out without PoE. Then we have our board here with USB-C. We plug this in. We take the Ethernet connection. There we go. There we go. So now if you wanted to have a sensor board or anything else with whatever kind of home automation, you could use this combination. Because this outputs 5 volt, we can input it directly into the USB-C plug of the QuinLED ESP32 ABE. And then we have all these pins we can use to connect sensors or other stuff you'd want to keep online using Ethernet instead of Wi-Fi. So next to doing all this LED stuff and having all this stuff on the QuinLED-Dig boards and stuff like that, you can also just run it like this. And I think there's smaller 5 volt versions, because this was a 5 volt 4 amp one. You can get a smaller one than that. But yeah, so you can also run ESP32 boards with PoE externally, just like this. So any project you're going to do, if Wi-Fi is sketchy and you don't want to use one of these, so with an external Wi-Fi antenna, which will get you much better range and stuff like that, you can still run PoE powered ESP32s. And I think, well, I don't know how much the Aliexpress solution is really, but I don't think the price will differ that much. So, yeah. So, let's see how we're going to do this. Because I also have these cables with it. Are we going to... do we want to test the cheap adapters first or the expensive adapters? So do we want to see if it blows up first, or do we want to see an actual use case? Because I already have this wired up, so we could test that, but... Cheap, 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 cheap. Bring on the smoke. Okay, okay. Let's see, because we have 5-volt LEDs connected right now. Let's start with 5-volt LEDs. 12 volt, 12 volt. Okay, so let's test these to start with then. This is 5-volt 4 amp, and this is 5-volt 2.4 amp. Okay, let's disconnect this one. And, well, it comes with a barrel jack. So we'll have to unscrew the power real quick. I think I've demonstrated the ability to keep the board online using POE enough for now. And that, as I said, for the new pre-assembled, that can be 5-volt or 12-volt or whatever. That's fine. But if you want to be on the safe side, just get a 5-volt version. So let's disconnect this guy. Yeah, we need that guy. Let's disconnect main power. Okay. And then let's connect. Hope these wires are going to reach. Oh no. There's epic music in the background. Assume this is regular 5-volt standard stuff and not PD. Yeah, the board doesn't do any PD or anything like that. You could feed it 9, 12, and 15 volts for standby power on the new pre-assembled, but yeah, like the combination of ESP and Ethernet alone, so we'll use it. Yeah, we'll use it more than W. Absolutely, it has a lot more functions than WLED alone. Okay, let's connect our POE splitter, which has 5-volt 2.4 amps output, to the board, and let's connect Ethernet. And then let's connect, I don't know. Okay, oh, okay. Well, we're online. But I made sure to keep the power limiter on. Yeah, let's see what that does. Can we change brightness? Yeah, I have the power limiter set pretty high. Or pretty low, actually. So we can, I guess we can change colors, but... Okay, we don't really have a way to measure right now. Let me think about that. Because I'd like to know how many amps are... You're going to watch a movie. What movie could be more exciting than this, Andy? I mean, you have to talk to this girlfriend of yours. Tell him you're watching The Blowing Up Dutchman or something like that. Make something up. Okay, let's run the power through a multimeter. And let's see if we can measure the amount of amps that are actually that we're getting from the splitter. Mortal Kombat. Sorry, boss. It's okay. Let's see here. I believe to measure power draw, we just need to pull it through the multimeter. Okay. I think we can do that. So let's do this. Let's disconnect this. Oh, wait, you can't see what I'm doing. Sorry. Okay. Let's disconnect that. Let's put this in here. That will work. Yeah, close enough. Okay, let's disconnect this tiny wire here. Don't like it. Yeah, this stick, this auto spinny stick is actually pretty handy. Okay, but now... Right, we're going to feed this in here. That needs to go through there, out of here. To there. And then this is minus. I'm making a stupid mistake, you guys will tell me, right? Doesn't it have to go in between the plus line? Oh, that's a good point, actually. Let's do that. It's fine. Okay, in the plus. And then I have to disconnect it here. Into the plus. And then I still need a minus line. I'll keep it in the screen once it's on. Minus line. Well, I guess I could just use a DuPont connector. I'm using all the wrong colors here. Okay, let's screw that in. Well, that's pretty tight. Okay, I need to get this out of the way. And this is then... No, this doesn't have the right plug. Okay. Too bad. OCD already tripped. Yeah, I get it. I get it. Sorry. Wait. Oh, okay, that's good. So, okay. To not trigger your OCD anymore, let's use black from here. Oh wait, and I'm actually wiring it into the wrong terminals too. Oh. We'll get there, we'll get there. Okay. So, plus that is running through the multimeter. Good enough. And then we need negative. That is coming out of the plug. I'm just going to make a mess of my table here. Don't care. Well, I care a little bit. Right, let's double check this, okay? We have this plug, okay? That will come out of the POE splitter, go in here, and then the minus wire is black, and it'll go straight into the minus input of my QuinLED-Dig board as the main power input, also black. So that's good. Then we have plus or positive coming out of here. It goes into the multimeter, into the fused input, and it comes out of the multimeter again after being measured and goes into the plus of the board. This is 5 volt 2.4 amps. LEDs are also 5 volt. I think he's new to wiring LEDs and QuinLEDs controllers. Be kind with him. So, with such a good product, what are your anti-scalper preparations? Making more? No, I don't know. Sounds correct. Yeah, I think it's okay. I think it's okay. So let's take this. Let's turn the multimeter on. I think it's set to 20 amps or something like that. Okay, yeah, okay. Of course, there's no Ethernet connected yet. Let's plug it in. I don't know. Yeah, okay. Okay. Ethernet's online. It's blinking away. Boards are online. What's the POE switch rated for? Actually, that's one from the last or the second last QuinBox. I don't remember. But it's rated for AT, so it can provide up to 30 watts of power. Okay, but this block says it'll do 2.4 amps. So, okay. Oh. You know what we can actually do? Let's turn that off real quick. Because we just want to see how much power we can draw, right? We could actually wire up 5 volt EXT to keep the controller online, even when POE power fails. It works, I'm disappointed. Yeah. Hey, we haven't turned up the power yet. Because otherwise I'd keep losing contact with my controller. That could be annoying. Okay. I like the WOWstick. The WOWstick's pretty wow. Okay, let's get this online. Oh, yeah, I don't have Ethernet connected. Let's connect Ethernet too. Okay. More LEDs. Ooh. Yes, well, this is 300, but they're really power limited. Okay, so it's actually drawing less power now, because if I disconnect 5V EXT, that means the 5V EXT power was higher than what's coming out of here. So this might already be voltage sagging. I can measure that with a second power supply. Power supply? Well, no. A second multimeter. Let's not go to Dutch, right? Okay. Okay, it's delivering 5.0 volts. Okay. And the brightness limiter currently is set to 1200 milliamps. Let's set it to 3000. Because the board should stay online even if POE doesn't. Okay. POE is now outputting, or the splitter is now outputting 4.9 volts. And we're seeing about a 2 amp draw. Okay, well, that's pretty good. Because this is rated for 2.4 amps. Okay. Dutchman blows up his garage by connecting too many multimeters. Yeah. Okay. Okay, let's go up in the power slider. Oh, okay, it's still being limited. Okay. You know what? Let's take the power limiter off. Okay, power limiter is off. Let's crank up the brightness. Okay, 2.5 amps. Ooh, 2.5 amps. We're down to 4.8 volts, but that's not too bad. It's unplugged. The 5V EXT is currently unplugged. So if it reboots, we'll see it rebooting. Let's turn it to red so that we know if it reboots or not. Okay, or blue. Yeah, let's turn it to blue. Okay, let's up the power more. Okay, we're at 2.68 amps off the cheap POE splitter. That's not the cheap POE splitter, but it's a fairly cheap one. 2.68 amps at 5 volts. Nice. Let's go to a dual color. Whoa! Oh. We're now drawing 3.46 amps. The voltage has sagged to 4.7 volts, but somehow it's still staying online. Because if we do the math, 3.5 amps at 5 volts, that is... I can't do math while I'm streaming. I don't know what that is. We're drawing 17.5 watts. But there's going to be losses that are taking place at some point. So... yeah, I didn't expect it to hold up that well. Oh, okay, it's getting warm. I mean, it's rated for 2.4 amps. And we're drawing a lot more. So do we want to try white? Let's do white. Uh-oh. Oh, okay. It rebooted. So let's turn down the brightness and go to white. Well, white is a bit blue here, but okay. Okay, let's turn it up. 3.2. 3.5. No, okay. Oh, we're right on the limit. So anything... Let's go back to white. 3.43, slightly up. 3.5. Okay, 3.5 is definitely the limit of this adapter. It's getting hot. Okay, let's keep it running at let's keep it running at 3.13 amps for a while. Hey, this is just the first POE splitter, so don't count out fireworks yet. Yeah, I'm not sure. This is probably like a $7 or $8 converter because it's 5 volt instead of 12 volt. And I know for the 12 volt one, I get a really cheap one. This was just a normal one. We have a better one over there. 2.4 amps continuous. Yeah. Okay, so it's drawing. Oh, okay, it's doing 3 amps pretty well. Well, to pass, you will see. I think this is mainly Chinesium certified. I mean, I'll have to go. Okay, thanks, Andy. Bye-bye. Maybe cheap 12-volt one plus buck converter would be a good combo. But yeah, but then you'd need to buck convert like 3 or 4 amps. So you need a big buck converter, and those are like $10 a piece alone. So, I think I have this one listed in the description. I don't know the price. I can check, right, I guess. Let me check my Aliexpress real quick. Yeah, well, I'll see you, Andy. It's holding 3 amps. It's warm. It's hot, but it's holding it for now. POE. Yeah, the tiny screwdriver is a WOWstick. It'll be in the next Quin box. Let's see here. 12 volt, 12 volt, 5 volt. Oh, yeah. Oh, okay. That's pretty cheap. Let me share a link real quick. Hold on just a second. Uh-oh. Oh, it died for a minute, and now it came back. Okay, so it can't hold... Ow. It's hot. It's hot. It can't hold 3 amps. Okay, that's fine. Let's see here. Okay, so I paid... no, let's go to dollars. Come on. Save. Yeah, this POE splitter, the 5 volt 2.4 amp one, this exact one we're using, was $7.50. Let me get you a link for that. Let's see here. It's the first one in this link. And this would probably be perfectly fine to keep an ESP and like a sensor or something like that online. Just, you know, it's rated for 2.4 amps. We're drawing 3 amps from it before. I think it actually did pretty well. And this was $7.50 with free shipping. I mean, that's pretty good. Yeah, that's pretty good. Okay, let's move on to the more expensive. Let's unplug this. It's really hot. It's really hot. I mean, you shouldn't use it for these kind of amperages. Just use it for like 2 amps max. Okay. Let's see here. Well, let's take the more expensive tester or splitter. This one does 5 volt 4 amps according to its rating. Well, we'll see about that. And the nice thing is, it just has the barrel plug over here. No, it's the wrong kind, Andres. It's the wrong kind. Okay, I need to prepare this real quick. Cat 5 is also heating up. No, I mean, that's running like 48 to 50 volts. It'll take a lot more for that to heat up. Okay, this one goes away. Plus goes through the multimeter, so we need to connect that. And then minus goes through the cable. Yeah, this WOWstick, as I said, I'll show it off in a Quin box. The next one that's coming up. Yeah, first day using it, but I like it so far. Okay, let's plug this in here. There we go. So we have a plus, again, 5 volt, 5 volt, running through the multimeter and then through the multimeter into the QuinLED-Dig-Quad, because that has screw terminals for 5 volt EXT, but we're not using 5 volt EXT right now. That's all fine. Let's pull. Something's beeping. Oh, my multimeter's beeping because it was on too long. It doesn't like that. Okay. I was like, is my camera dying? But it's on AC power. How is that possible? Okay. Okay, there we go. LED's lighting up. I'm trying to keep everything in the shot. Ethernet's online. So I should have my WLED page. I do. Okay. POE is 15 watt. POE Plus is 30 watt. Yes, but there's always going to be losses in the line and in conversion and stuff like that. So effectively, you're only going to have about 20, 22 watt, something like that. Smoke alarm! Oh no! Okay, so this converter is doing 2.27 amps. And let's see what the voltage is right now. Okay, 4.9. Okay, that's fine. Let me see if I can do this in a way where I'm not blocking the shot halfway. No, that's not going to work. Something like that. Okay. Let's put it to full power. Full power. Okay, that's not enough. Let's go to white. Full power white. Wow. 3.94 amps. Okay, the voltage did sag a lot, but I'm actually seeing voltage drop on the strip even. That's how much we're pushing it. Okay, yeah, it's going above. Oh, I need to disconnect it. Now, I don't know how well this would work on older type boards, because this board with my own custom DC-DC circuit on there is a lot less sensitive to fluctuating voltage and low voltage and stuff like that. On the old boards, if your input dropped to 4.7 volt, that could have already been it. So the controller would reboot and stuff like that. These new boards, as I said, can take up to 4.5 volts down, and the ESP and the level shifters and stuff like that will still get 5.1 volts through magic conversion stuff. But yeah, that's actually a lot of amps going through there. Wow, that's pretty good. That's not hot yet. That's okay. Well, I guess we'll leave that running for a little bit. Let's re-chat. Screw in the probes so that you don't have to hold them. That's a very good plan. I'll do that for the next test. Is one Dig-Uno enough for 35 meters of LEDs, 7 times 5 meter, and what's the advantage of a POE splitter versus 5 volt power supply? Well, the advantage of a POE splitter instead of a 5 volt power supply is if you want to use POE. If you can just have a little phone charger there, then I'd absolutely take the phone charger above this construction. It's also going to be much cheaper because like a $3 phone charger will keep the board online just fine. So there's that. And 7 times 5 meters is a lot. The Dig-Quad is rated for up to 30 amps continuous and 50 amp peak. So you'd have to look at the power sheet. That is on QuinLED.info. Calculate how much power you're going to need, and then you can determine if the board can handle it. There is a power injection live stream linked in the digital LED section, and that'll take you through all the steps figuring out your whole setup. What cable are you using? Does CCA or full copper matter in this case? Yes, it does. CCA basically isn't rated cable. So if you're using CCA, everything's out the door. If you're using CCA Ethernet or copper wire, whatever, any rating that is ever given doesn't apply anymore. Don't use it. Simple as that. If you're using normal copper wire, yeah, this is all fine. Oh, thanks, Philip. That strip is going to get smoky. Yeah, this is just one of my testing strips, but it is getting warm. That's for sure. Oh, okay. Yeah, there's maybe a warm spot on the POE converter or splitter, but I guess converter is a good word for it, because it's converting 48 volts or 50 volts to 5 volts. That's a tenfold down conversion. Damn. Yeah, that's true, Johnny. I just never use CCA for anything that has a rating for copper. I mean, a moderator's being moderated? What? Hey, what the hell? Why did Google delete that link? Can I undelete that? No, I can give Philip a timeout, but I don't want to do that. Huh. Yeah, okay, link is there again. Cool. What the? Does the standard WLED recognize the Ethernet shield? There is a special Ethernet version of WLED. You can just download those with the normal releases. And the QuinLED ESP32 Ethernet is there in the selectable Ethernet board list. Yeah, it seems Google doesn't like it. I don't know. Damn, okay. Let me see if I can post it. Let's see here. There we go. See if it deletes that. Google has Uber moderators. Yeah, that's for sure. Okay, well, this is working. Wow. Didn't expect that. Okay, oh, well, okay. Yeah, one side of the Ethernet or the PoE splitter is getting hot. It's beyond warm. I can still touch it, but But this is running, well, you can see, this is running 4.07 amps. So if you'd run like 3 or... yeah, if you're running 3 or maybe 3.5 amps, I can imagine this converter being fine. So actually running some 5 volt LEDs, I mean, if we just do a popular effect I like, if we go to the palette effect, even at full power, and the brightness limiter is off. And this is WS2812B Eco. So it is the slightly more efficient variant. But it's only drawing 2.8 amps for running 300 LEDs. And the brightness is decent. We're getting 4.9 volts, so that's fine too. Of course, I don't have an injection at the other end, because then they'd use a bit more power. Because it's 300 LEDs, and you kind of want to front and back feed that. But for normal effects like this, well, I already have a FLIR temp camera. Nah, the FLIR is a bit nasty to set up, so... Yeah, exactly, Air Cookie. If you put it like, for this converter, right? So for the premium 4 amp 5 volt converter, if you limit it to like 3, maybe 3.2 amps, something like that, I can see that working. I mean, and the switch I have connected, it was in the previous Quin box. It was like a $45 switch with an internal PoE power supply, and I can't read the switch. It's a dumb switch, basically. So, but yeah, that's fine. No problemo. Because now we're doing below 3 amps, and yeah. Okay, that's better than expected. Have to be honest here. I mean, this is a... how much was this converter? Okay, we're currently testing this converter, and it is $15. Well, sub 4 amps, no, but maybe if it's 3 amps continuous and we limit at that, from these initial testings, that's not too bad. And it's rated for 4 amps. I mean, oh, my multimeter is complaining again. That means we've been testing for a while. And voltage is fine. But yeah. Yeah, they have some loss, of course. Yeah, that's right, Killer Geek. My strip is cooling down finally. That's good. Yeah. Okay. Yeah. Agree with Air Cookie again. Normal power supply is better in most cases. But if you have something which has like 100, 150, 200 LEDs in there, and PoE power makes more sense in that regard for that situation, I can't complain about it just working. Yeah. Wow. Okay. Interesting. So it's good that I bought different versions, I guess, because the one we tested before, I'm not sure. Oh, this one. The 2.4 amp rated one. It's cheaper. It was half the price. But then again, I wouldn't use this above 1.5 amps. And then this one is twice as expensive, but as we can see, it'll handle 3 amps fine. More LED! Push it until voltage drops. Well, it already dropped. You can see that. So if we push it to, let's see, if we set it to white, effects solid. There we go. This is full power white. We're getting voltage drop on the LEDs because we have to double inject for that. But the converter is still giving out 4.8 volts at 4 amps. So, yeah. I got the adapter, Nicholas, and it does work. The included camera isn't too great, but I didn't buy it for the camera. I mainly bought it for the focal visual stuff. I might get a better camera in the future, but with the adapter, it does work. It's not awesome, but it works. Yeah. Do you have any experience with Highlink 230 volts to some other volt? No, I don't. I've never used the Highlink stuff, but I've seen other projects which have used it, so yeah, it's all fine. And now it's getting warm again, but we're drawing 4 amps. I mean, come on. Cool. Okay. No smoke yet. How long have we been going? 1.5 hours? Okay. I'm just gonna disconnect this. I couldn't even get this thing to crash. Okay, yeah, at 4 amps it does get hot. I wouldn't use it at 4 amps, but 2.5 to 3 amps, running normal effects, I think it'll be fine. Damn. Okay, that's cool. Okay, let's disconnect that. And let's disconnect this guy. Because that is the brilliance of the new QuinLED boards. Now I can just connect this here. And this is a 12 volt LED strip. You can't see it on here, but it's WS2815. Whoa, Philip, we want smoke. We want smoke. We want smoke. We're not done yet. We're not done yet. So let's start with the powerful adapter first. This will do 12 volt 2 amps. Okay. And this is 144 WS2815 LEDs. And basically, because the board is now fully auto input, I just connected the different LEDs. I don't have to change any jumpers or anything on the board. I just plug this in. And I plug this in. Well, I need to configure the LEDs. Hold on a second. Yep, Ethernet's online. This is now pin 1, I believe. Need to adjust the amount of LEDs. Yep. Cool. Okay. Oh, right. We were going to screw in the multimeter. Sorry about that. These are my better multimeter plugs, but we'll do it. We'll do it. Okay, that's tight enough. It's a giant mess of wires here, but okay. Nope, wanna wait. Tight enough. It won't explode. Yeah, okay, okay. This is still on the screen somewhat. Okay, let's do it. Pew. Okay, orange. We're drawing 1 amp for 144. I have another string so we can double that if needed. Let's go for broke. Full power orange. Okay, we're seeing 11.92 volts, but this is again the expensive adapter. But it's up to, okay, 1, 2, 6, 7. Let's go to half brightness and then go to white. Actually, that doesn't matter because it's WS2815. Yeah, it doesn't matter which color I choose. Yeah, it's WS2815, so it's really inefficient. So any color I choose at full output is going to use the same amount of power. Not unlike 5 volt or WS2811. Okay, so it doesn't matter. Okay, so running 144 12 volt LEDs seems fine. Let's you know, leave it hooked up for a little while. Trying to keep everything on the screen, but it's difficult. It's giving off a really tidy 12 volt. Johnny says, I put up a microscope adapter you can print, I believe, on Thingiverse. Awesome. Arnold says, I think something with the QuinLED will be interesting, especially when there's a relay to switch the big PSU. Yeah, but there's multiple GPIO pins, and as I said, the production version of the pre-assembled Dig-Quad will have a Q1R pin over there, which will have 5 volt output, so you can use that to switch the relay like one of these cheap $2 relay boards automatically, and then you'll have your relay to switch your big power supply. And of course, we're now abusing all of this to actually power LEDs. I'm still standing with the point that that shouldn't be your normal application. It should be to keep the board online. But, you know, if it works, it works, I guess. There is a BT standard POE splitter in Aliexpress that delivers 5 volt 6 amps or 12 volt 5 amps. With the new POE standards, it will be possible to power LED strips in production. Yeah, wow. But, Rob, how much does that cost? I mean, how much is that adapter alone? Let alone the switch for that adapter, because you don't get a $40 switch like I have that can run BT. How much is that adapter just by itself? Ethernet responds a lot. Yes. If you're running pixels, or even the interface of WLED is much faster running over Ethernet like we're doing here. Does Wi-Fi do fallback if Ethernet disconnects? No, not in the current versions. I'm not sure that's possible. Do you know, Air Cookie? About 25 euros for the adapter. Okay, so it's either 20 to 30 amp power supply or 5 volt 6 amp adapter. I guess if you want to run PoE and you'd rather run a Ethernet cable, or you have Ethernet there instead of mains power, it could be a trade-off you could make. I mean, I can see that. Powering LED strips over PoE actually makes sense for outdoor stuff. Yeah, I can see that too, Johnny. And if it's like props doing like 100 to 200 LEDs, if you don't demand like full white bright output, that's my multimeter again. Running these kind of adapters, I mean, this one isn't even getting warm. Okay, let's connect the second string. Wow, okay. So I kind of stand corrected on running LEDs over PoE, but I am going to stay with the fact that making a PoE hat, basically, or making this adapter do PoE doesn't make sense because, well, that's kind of why I was saying this initially already. You can just do it with one of these external blocks that are made for it, and I don't think I could even make it for the same price. Okay, let's do... Oops. Okay, I put in 288 LEDs, but of course that upped the amperage immediately, so it rebooted the board. It did save it. It did save it. That's good. Okay, the board is back. Let's set it to red, just, so we can see it reboot. I would suggest using dump power injectors instead of PoE for the outdoors use case. Does not require an expensive PoE high power switch. Yeah. Or dumb. Yeah, sure. Yeah. Okay, let's see what we can get. Oh. Well, we can't get much out of this adapter. So now we have 288 WS2815 LEDs connected. We're doing 1.9. Then we refresh the web interface. There we go. Okay, even going to 1.99, the adapter trips and it reboots. So it looks like you can get... this would be 24 watt. And for the 5 volt one, we got 20 watt. So this one was able to do 20 watt, but I'd run it slightly lower, like 15 watts, so 3 amps 5 volt. This one is really 2 amp rated, but even doing 2 amp, it doesn't get too hot. So let's see if I set the brightness limiter here. Let's see what it does. I have to find the value to not trip it, but max it out. Oh, 1.8, that's fine. Yeah, I mean, that works. And this one doesn't get too hot. I once found PoE to USB-C that would deliver Ethernet and power for a tablet. Can't find it anymore. Oh, okay. Okay, so this works for 12 volt. Let's try one of the cheaper 12 volt adapters. And I think we're done testing after that. What do you guys think so far? If it's me, this is actually working better than expected. Oh, let's try that cheap one. The cheap one. There we go. So this one says 12 volt 2 amp. 12 volt 2 amp. 12 volt 1 to 2 amp. Okay, let's try the cheap one. I have to solder my different plug again. Hold on just a second. What do you guys think? Were you expecting this? Did you think it was going to work better? Do you think this is a jank solution and this isn't PoE at all? Do you think, hey, I didn't think about this. That's actually brilliant. That's what I think. And, yeah. Does this mean I can now say that the QuinLED stuff can do PoE? I mean, I think it does. Nope, that's the wrong one. Yeah, but like Johnny said, if you're doing props outdoor and you're doing like 100, 150, maybe 200 LEDs, you can run a 100 meter or like 300 feet, I don't know how long that is, Ethernet cable, run PoE over it, and it'll be fine. That's more than the 10 or 20 LEDs I thought it would do. Yeah. Okay. Let's see. This is 12 volt. Yep, 12 volts. Power. Okay, lights up. It does 1.8 because we had a giant amount of LEDs connected. Oh wait, we have the brightness limiter still on. Maybe I should plug in Ethernet too. There we go. LED preferences. Let's turn the brightness limiter off. Do I want to do that? No, I don't want to do that. Hold on. Let's turn the brightness down. And then let's turn it off. Save. Okay, so we're at 288 WS2815 12 volt LEDs. This one is only outputting 1.4 volt at 0.7 amps. So this one is already a lot worse than this guy. Wow, okay. Let's go up. 1 amp, still at 11.4. 1.5 amp. Oh, it tripped. But why did it trip? Let's do that again. 1.5 amp. 11.3 volts. Damn. 1.76. Yeah, okay. It trips around here. Okay. So this one won't deliver a lot of power. Let's leave it running for a little. Wow. It's dropped to 11 volts. It's a... Uh-oh. It's going down. It's going down, Captain. Oh, no, no. It's not doing it. Oh, it's dead. It's not booting anymore. Yeah, it doesn't deliver the output voltage anymore. Nope. It's saying nope. Let's disconnect the LEDs. What the? What's going on? Did we break it? Is it dead? Okay, I disconnected the Ethernet. It's dead. No smoke, but it's dead. Well, this one was only $5. But I mean, yeah, no. Yeah, no, this is not working. You can see the LED on the QuinLED trying to boot up. But, and here, all the LEDs are disconnected. So it's only drawing like a watt maybe at most. This one's broken. Okay. Okay, this one's dead. Let's leave it off for a little while. Let's see what happens. Sure, but we were drawing 4 amps before. This only has the Ethernet board and stuff connected, so that's maybe 300 milliamps or something like that. Okay, let's connect it one more time. Didn't disconnect any wires or something like that, no? Okay. Oh, let's see. Nope, no, no, nope. Nope, nope, nope. Okay, this is a lot of nope. Cheap POE splitter. Maybe to keep the board online, it would have been fine. I think so. I mean, that's, as I said, maybe 300 milliamps, a few watts. Yeah, this one's dead. Fine. Okay, let's go to this one. This one's from the same supplier I linked earlier. I think I still have that link. Let me see here. Yeah, I know multimeter. Why do you sound like a smoke alarm multimeter? That's just dumb. Okay. Yeah, I guess we connect this one. See if maybe it didn't kill everything. Let's hope not. Oh. Okay, 12 volt. Ethernet's online. Oh, yeah, I disconnected the LEDs. Okay, yeah, so without the LEDs, that's a good point. As you can see, we're drawing 0.12 amps at 12 volt. So the board itself only needs a minuscule amount. You sure you didn't smoke the PoE switch? That's a good point. But no, it's okay. This new adapter works. Let's connect the 12 volt LEDs. Okay. It's back to orange. What the? What the? What's going on here? Whoa! Did you guys see that? So, we're doing 0.9 amps, 12 volt. 1.23 amps, 11.9. Okay, that's fine. What the? 1.3 amps, we're doing 9 volts. We're doing 8 volts. Can we get down to 5? 6 volts. 5 volts. It's the only reason the board is staying online is because of the custom DC-DC circuit, which is auto input everything. Let's see if we can max it out. 4.6 volts. Oh, the LEDs are starting to blink. 4.5. 4.4 volts. And, well, the auto DC-DC circuit is working excellently. But this is just crap. Whoa, okay. Yeah, don't buy this one. Yeah, I mean, whoop. Wow. Okay, I cannot recommend this one either. That's unexpected. Or I guess the buck converter in it is just failing horribly, but wow, okay. Then let's go to the higher quality 12 volt 2 amp one. It's again from the same seller, but this is a more expensive version. Okay, let's do that. Let's do that. Or it could be the PoE switch that died, but we'll see. We'll see. No, see, this one's doing 1.9 amps at 11.6 volts. That's respectable. That's okay. And this one is 2 amp rated. Yeah, okay. Well, it won't do more than 2 amps, but it'll do 2 amps. She can't take any more, Captain! She's gonna blow! Okay, my Scotty impression is pretty bad. Oh, this one is fair. This one just won't do more than 2 amps. Okay, so I'm altering my conclusion a little bit. PoE can do LEDs as long as you get expensive PoE extractors, right? So these are 15 bucks each. 5 volt 4 amp, I think that's the best one up until now. Or this one, which will do 12 volt 2 amps. And I guess this one is also doing 12 volt 2 amps, but yeah. Yeah, I get that. Let me share the link to this one directly. Oh no, I can't. It's from the listing I said earlier, but they do actually differentiate between 1 to 2 amps, which was the horrible one, and these actual 2 amp versions. But yeah, it's gonna vary depending on what you get. That's absolutely true. Air Cookie on Aliexpress. If you buy a cheap one, that will be fine for running 5 volt EXT, right? So to keep the board online, connect a relay to it, and then switch on and off your big power supply. And that's kind of what I intended this PoE solution to be. To keep the board online, maybe run a few sensors if you're running an ESP32 board directly, and if you're running LEDs, use the relay board to turn on and off your power supply, and your controller stays online with minimal power usage. And, well, that's going to work fine with any of the adapters we tested today, because as we saw with 12 volt, it's drawing 0.1 amps. I think that's going to be fine with any adapter we tested today, even the blown up now horribly cheap one. If you want to run LEDs over PoE, and I think this is going to be the real conclusion, cheap adapters, your mileage is going to vary a lot. And more expensive adapters, and I have these linked in the description, are going to do better. I like the 5 volt one the best, because I think we can get an actual 3 amp, 3.5 amps out of that, and that'll work fine. But this 12 volt one also, this is the 5 volt one, this 12 volt one also worked pretty well. It just cuts off at 2 amps straight, but it'll do those 2 amps, I think. Yeah. 380 watt PoE switch, PoE++, damn. Yeah, agreed, Killer Geek. You need a decent PoE splitter to get some decent amperage out of that. But more than 3.5 amps at 5 volt or 2 amps at 12 volt, I wouldn't expect. I think those, even for the best adapters, are going to be the maximum you can get out of a cheap-ish PoE switch. Unless you go PoE++ with 70 watts and blah, blah, blah. Maybe, but yeah. Yeah, BT power modules, yeah. But then you're paying $25 for the PoE adapter, so, or 25 euros. So you should have a really good use case for that. Yeah, okay, up to 65 watt, sure. Is that effective, or do we still get losses? I wanted to click your link, Johnny, but Google removed it before I could click it. Effective. Okay, that's pretty good. You'll have to wait slightly longer. Michel Zuck? I don't know how to pronounce your name. Sorry. We're going to be launching some stuff next week. Probably Discord only for now. So if you're there, you'll see the announcement. And then I hope to have actual widespread availability. Yeah, I was going to say end of this month, but it might slip a week. But very, very soon. And then the new Dig-Uno, the Dig-Quad pre-assembled, the antenna version of the ESP32, the board antenna version of the ESP32, those will all be available. And we're going to do a trial version of this one soon. That will be a Discord announcement only again. And then once the trial basically works fine, we're going to make these en masse too, and they'll be available somewhere next month, I hope. Yeah, this is fine. It was on the LED, so it's a bit hot. Let me put it over here. They don't like your affiliate stuff. Yeah, I guess so. I don't know. I've seen other YouTubers post links and stuff like that, where their moderators can post links. I'll have to check the settings, I guess. But I don't know. Okay. Well, as the music is foreboding, I think we finished all the testing I kind of wanted to do today. I'm cooking my LEDs a bit. Sorry, I have to leave here for the Secret Python live stream. Well, we're going to round off anyway, Johnny. Thanks for being here. The link I posted was no affiliate. Yeah, that's true, Philip. But yeah, do with this stream as you wish. Form your own conclusions. As I said, I think these adapters linked down below are going to do well if you want to run some LEDs. But PoE, For keeping the board online, you can get the cheapest adapter you want. That's going to be fine. Make sure it's an isolated adapter, but most of them are. That's fine. If you want to run LEDs, get the $15 more expensive converters. And those will do okay, I think. I mean, this is the only testing I've been doing, so this hasn't been a 5-day POE test, blah, blah, blah. I also don't know if your switch is going to handle it, or what your cables are going to do, or... Well, I tried to blow... we killed one Philip. We killed this one. This is dead. But no smoke. Maybe if we open it up, there's smoke. I don't know. But, yeah. The POE, I guess it can work for LEDs. And, well, I'm just going to say that my boards are fully POE compatible. So, let's round off in a few minutes. What do you guys think? Tell me your thoughts. What would be fried if you accidentally plug POE directly into an ABE? Nothing. Because it doesn't request POE, so it'll just come online. Do you want me to try? We can try that. But POE is basically asked for. So, if you're not asking for it... well, yeah, okay, let's use this board. Let's use a prototype board instead of a trial board. POE cable I just used. Well, yeah, that's not going to do anything. Let's add USB. What the? David, that's fine. Why is it YouTube moderating my chat? Sorry about the retracted message, or maybe you did it yourself, David, not sure. Yeah, if you're using a dumb adapter, you'll fry the board. Easy as that. But if you're using an intelligent POE switch or an active POE injector, I have a whole video about POE in regarding to IP cameras, so you can look at that. All active, passive, 48 volt, 24 volt, stuff like that is in there. But yeah, using a POE cable from an intelligent POE switch, that's fine. It's a dumb switch, but it's active POE basically. Yeah, if you don't have any dumb injectors, you don't have to be that careful. And the nice one about these splitters is that they are active splitters, so they will actively request POE from the switch basically. So you don't have to use a dumb POE switch or dumb injectors and stuff like that. If you take a POE adapter or connect it with reverse polarity, do the POE splitters blow? You really want to see smoke, huh? I don't know. Well, let's take this one. The 2 amp one, that did okay. We can rig it up to blow, or see if it blows. Let's deconstruct here a little bit. If you put a passive power in a non-POE, okay. Hold on, we don't need this anymore. Can you at least blow off some capacitors? I know it's a bit disappointing live stream like this. It works better than expected. I guess that's disappointing. And we unscrew this one. Okay. Now let's prepare this plug. Okay, then let's disconnect this. You want to see QuinLED reverse polarity protection? Because that's another feature of the board, which is, well, it was always there, it's just improved again. Shouldn't be able to blow it up. Shouldn't. That's the, you know. I'm going to disconnect my LEDs just to be sure. Michael Hoffman says nothing but donates $5. Thank you very much. At least one died, as expected. 30% failure rate on the cheap stuff. Yeah, Yeah. Okay, so... Oh, I did this wrong. Actually, no, I did it right. So, plus is going to here. Minus is going to here. That's the wrong way around. And you can verify here, because here plus is red and here minus is black. Let's plug in the POE adapter. I'm not going to plug in an ESP or anything else. Let's see if it pops. You guys ready? Oh, it has lights. That's cool. Okay, so reverse polarity POE. Nothing's happening. What about if I disconnect this? Okay, there's a light now. I'm not sure this one survived. It's dead? Did I kill it? Okay, let me hook it up the right way. We might have killed another adapter. Well, you guys have been donating so I can buy new adapters. That's fine. I actually bought these to test anyway. Okay, so now plus and minus is connected the right way. And let's see if it fires up. Okay, the power LED is online. Let me get my multimeter to see what kind of power we're getting. It's not doing too great. Okay, let's put an ESP on there. Let's see what it does. Yep. Let's connect that. And let's connect power here. Okay, so I've seen this before. Basically, there was no load, and without any load, it won't be able to send out a stable voltage. It depends on how you design your buck converter circuit. Now that the ESP32 is on there and the Ethernet port, which is online, can't see it, but it's online. Now that there's a bit of load, output voltage stabilized, and now it's working fine. So I tried it, Philip, but even reverse polarity, it didn't break. Yeah, it probably has some reverse polarity protection. If there's a buck converter in there, most of the time buck converter circuits can basically detect when there's a short, and then they just disable their outputs. And yeah. Yeah, this thing is called a WOWstick. And so far I like it pretty good. It's, yeah. Thanks for all the research and sharing it with us. Thanks for watching, Draadstaal. And, well, thanks for the donation, of course. Yeah, so, wasn't able to kill this one. It's okay. More POE adapters for me. Okay, well, that's actually going to be it. Let's sit down for another minute, talk about this, and then I'm going to end the stream. So, that was interesting, because as I said, I verified the concept. I mean, I tested it slightly before, like for a minute, to see if it could actually work, which it should in theory. And, well, it didn't disappoint. Using POE to keep the board online for 5V EXT is going to be fine with any adapter you can find. And if you're using a V2, V3 pre-assembled one, so V2 for Dig-Quad or V3 for Dig-Uno, you can just get a cheap 12V one, run the board 5V EXT power off of that, and you're going to be fine. And as I said before, this is the third conclusion I'm doing. If you want to run actual LEDs, get some of these better converters. Nope, over here. Those are linked in the description. They're a bit more expensive, like $15, but it could actually save you a power supply. And you could run like 100, 150 LEDs without many limitations, really. This was 300 LEDs. Yeah, pretty well, I'd say. That surprised me. It's a $15 adapter, but yeah. And then you could have, of course, run these without Ethernet or with Ethernet on the board. But if you get a QuinLED-Dig-Uno or Dig-Quad ABE or a QuinLED ESP32 ABE, you can plug in the Ethernet, and then you're no longer dependent on Wi-Fi whatsoever. It's fully Ethernet enabled. And that's been working fine the whole stream too. So I think the trial batch will release soon. We're not going to have too many complaints, and we'll go into production with that too. Thanks for all the research and sharing with us. And Philip, another €5. Thanks a lot. Thanks for trying anyway. We'll have to YouTube some blowing components. Yes. Team up with Electroboom. Oh yeah, he'd probably get it to blow. Yeah, Air Cookie says Electroboom injecting 230 volts into POE. That'll do it. Fairy lights would do great if that. Yeah, actually, I have some. Want to see a secret? We're at the end of this. We're at the end of the stream where I start revealing all my secrets. Hold on. I've been testing this stuff. I'll show you in the overhead camera. How many people are still here? 137. Okay, you guys are the real MVPs. This is WS2812C minus 2020. So they're very tiny LEDs. I mean, if you compare them to a 144 LED per meter strip, you can see the LEDs are really tiny, but there's 198 per meter. And I've been testing these recently, and well, they are the most efficient LEDs I have seen, well, ever. I think like 2 meters of this, so that's 394 LEDs or something like that, uses only 15 watts, maybe 20 watts. Even set to single color or dual color. I don't remember completely, but they're really tiny LEDs and they're really, really efficient. It really surprised me. But more about that in the future. Hey, you guys stay here for the secrets, right? Up to 2-3 meters fed by POE. That's a good conclusion. That's impressive. Yeah. If you get a good adapter. What are the actual euro prices and difference between all the QuinLED boards? Look at the website. Or look at my previous video where I did a whole update on the boards. And, well, in the future, you can mix and match what type of board you want with like a board antenna or external antenna or Ethernet and stuff like that. And that will have some different prices, of course. But, yeah. Look at the website in the digitally adjustable section. There you'll find most of the stuff. Okay, I'm very bad at ending streams, so I'm gonna do it anyway. Thank you guys so much for watching. Thanks everyone who donated. That'll actually offset my my blown up POE splitter at least. And if you want to check out some, if you want to check out those POE splitters. Check the video description. They should be there. And otherwise, I'll catch you guys in the next video. Thanks for watching. Bye-bye.